Hi everyone, and welcome to a new episode in the Multiverse video series. I'm Javier Luraski, and today we're going to learn how to use MLflow from R. Now, before we get started with exactly what MLflow is, I want to give you an overview and a problem statement of why MLflow makes sense. And for that, I want to set the problem in the context of what Tesla is doing with autonomous driving. There is a talk from Andrej Karpathy, who is currently leading the full driving technology at Tesla, in which he explains what are the concepts and the type of processes that they need to implement in Tesla in order to build autonomous driving systems. And there's one part that is probably expected, that if you're following things like deep learning, TensorFlow, and Keras, you would expect that in order to build an autonomous vehicle that uses computer vision to navigate, you would expect Tesla to be using things like deep learning models. And they're obviously using them for training their fleet of cars. Now, those are not big news. It's also the case that they have a lot of data. So in order to train over, thousands or millions of videos, and sensor information from the car, you probably also need a distributed system using technologies like Apache Spark or why not. Now, the part that is surprising, or it was at least surprising to me when I look at this talk from, when I watched this video from Andrej Karpathy, is like one of the problems is also to figure out how to organize your training, your data sets, and how to get all that working. So in this particular slide, what Andrej is explaining is that in order to have a system that can improve over time, and the system meaning the actual self-driverless car, you can't just have like an original data set where you train all your videos and why not, and then deploy it to the car and be done. It just doesn't work that way, right? And in most companies, that are dealing with data and that have a team of data scientists, you don't do just one analysis once where you get the data, you apply a model, you create some, measures or model out of that you can use in production or why not. It just doesn't end up there. You usually need to iterate, and you probably, in the case of Tesla, they might have started with a simpler model, and over time it just gets better and it gets improved. Now, the problem is that there's a question of how do you manage the actual model and the actual data sets. Like when you are working with, with data sets, and when you're working with models that are constantly changing, it can be pretty challenging to figure out what data you're using to train something, which models are you using, and what is the performance of those models, and put them all together in a system that you can reuse to easily navigate what things are improving, what things are breaking, and make sense of all of that. Anyway, so you don't need to be training, self-driverless cars in order to use MLflow. But if this kind of problem sounds similar to you, where you, when it's not immediately obvious which are the models that need to be deployed to production and how your team is doing progress while training those models, and how close they are to achieving the goals that you're setting, you can consider MLflow, the MLflow project, to kind of like get you closer to having kind of like this modeling lifecycle system that can help you understand better what you're building, how you're building it, and how you're training those models. Anyways, so this is the landing page for MLflow. MLflow is an open source project with support for various languages, are included. And yeah, this is the landing page. Strictly speaking, from their website, MLflow is an open source platform for the machine learning lifecycle. And it has three components: MLflow tracking, MLflow projects, and MLflow models. Now, MLflow tracking is all about what the name says, which is tracking, basically. What are your measures? What are your metrics? What are your parameters? And how they evolve over time. And there's two other components. One is projects that allows you, in this case, to reproduce your runs. So sometimes it can be hard to, even though you might not even have the code, or even if you have the code, you need to figure out what is the environment that you need to reproduce something. In the R community, we have tools like previously Packrat and more recently renv. And actually MLflow makes use of Packrat, and hopefully in the future it will make use of renv to actually help you, track your projects and be able to reproduce code and models and datasets with ease. And then the last one is models. You can actually take a model and deploy it to production and kind of like easily interface between different cloud providers, and why not? Now, in this particular video, we're only gonna talk and kind of like learn how to use MLflow tracking. Maybe in other videos, we'll talk about projects and models, but I wanted to start with tracking, which I believe is the simplest and maybe also most useful functionality to get started when using MLflow. Now, to get started, all you have to do is go to the documentation site in the MLflow project. And I would recommend that you start with a quick start. And what you want to do is you want to select R. And basically, you will get some of the kind of like examples that you can just literally just copy paste when using R and getting started. So let's just go ahead and do that. And I should just say that, if this is the first time that you hear about MLflow and you're getting started, what you want to do first is just install MLflow. MLflow happens to be available in CRAN. So you can just run install packages, and that's pretty much it. I believe the first version might have been 08 and 07 actually. And since then, we're currently at MLflow 1.5. So again, it's on CRAN. You can just pretty much just run install.packages MLflow, and that's gonna give you the installation environment for MLflow. Now, the next step, what you want to do is you want to run MLflow, install MLflow, and I highly recommend that you install Conda. It requires actually Python. And it doesn't use reticulate, this particular package, but it does recall Python for running the actual server. So you want to install MLflow, install MLflow. Now, what is true is that for the actual tracking functionality, you don't need a server. The ideal setup is actually to have a centralized server that is running MLflow server, and then you can just use the client to log all your measures and tracking functionality from your models. And but just to get started, I would actually recommend that you also run MLflow, install MLflow with Conda installed, and that's pretty much it. It will kind of like create the environment and install all the dependencies that you need. So those are the only two steps that I run before starting this video: install packages MLflow and MLflow install. All right, so the next step is, as you would expect, you want to include this library. So let's just create a new R script. Actually, we could even create a notebook. Why not? But we'll go with a script for now, just for this video. And what you want to do first is run MLflow, and that would include the library, and make it active. And then you're gonna see that basically a lot of the functionality of MLflow is prefixed with MLflow, and you can take a look at some of the particular functions, but the ones that are interesting for the tracking functionality are the ones that start with MLflow_log. And there's things like log a parameter, log a model, log a metric, log an artifact, which an artifact is really just a file, or logging an actual model if you finish training it and you actually want to keep it in your kind of in your records. So what we're doing here is a very simple example. What we're saying is, suppose that we're trying to do some classification of some sort, and like usually it's the case that you might want to have different parameters on your script, and there's functionality on MLflow just to log parameters. If you're, maybe you're using the test set or and you want to know specifically which test set for which particular year or month or whatever. So you might want to load, have a script that is first of all parameterizable, and second, you might want to log those parameters. In this case, it's just a kind of like a very silly example. You're running, we're just calling parameter 1 and assigning that value. And, then we can log metrics. And the difference between parameters and metrics is parameters are expected to be logged only once, usually at the beginning of your file, while metrics is something that you usually update, right? So if you have iterations that you're, if you have iterations over your particular algorithm that are doing something significant, for instance, while training using Keras or why not, you might actually want to log the accuracy as it moves and as it improves through your model. So you would use log metric with different values, right? So on your first iteration, you would run with, like metric, in this case, just call foo equals, it's 1. And then, next iteration would be 2, and then next iteration would be 3. And that's pretty much it. Now, you can also log files, and, an artifact is just a file. So in this case, let's just create a simple file, which is output.txt, which we just have here. It says hello world, not super interesting. But then we can actually log it. And when you log it, it basically goes to MLflow, and that's pretty much it. Now, when you finish running, this particular instance, I think there should be instructions somewhere in here, but if not, we can do it. What you want to run is you want to run MLflow, and then you want to terminate your run. But before we do that, actually, before we close on this run, what we can also take a look at is, how does the UI for MLflow on the server look like? So you can say MLflow UI, similar to, if you're familiar with Sparkly R, Spark UI or Spark Web. And here the function is called MLflow UI. And what MLflow UI will open is basically just the user interface for MLflow directly from our studio. So in this case, what you can see is that, it's a brand new server. We just installed MLflow. And it's also worth mentioning that when you run MLflow in this through R, it basically creates a server while you're using MLflow, and this server is particular to your project. If you were actually running this with your colleagues, I would recommend that you actually follow the instructions on how to run MLflow as a server directly from the command line, and then you would have to follow the instructions here of using a remote tracking server, which should be somewhere in here. So you'd have to do some configuration. You install the server, you configure it, and then you set up which is your tracking server by specifying their URL here. So we don't have that to get started. We're just using a local instance of MLflow, which also means, as you can see here, there is a new folder being created on your project called MLruns. It's not actually interesting to look at these because these are just metadata that the MLflow server is using, but you're certainly welcome to take a look at it if you're interested in. All right, so we basically have this interface that is basically logging the output of what is called an experiment, which an experiment, again, can be either R script or a modeling, a generic Python modeling script or why not. But the interesting thing here is that that particular experiment has entries that we've dealt with. And in this case, I believe, this run is not even finished, but we can still take a look at the parameters that we logged. So you can see here that there's parameter 1, and it has the value of 5, right? That's exactly what we logged. And then there's the foo metric, which we updated 3 times, right? And you can see here how our metric improved over time. And again, this was a very silly example, right? We were just updating the metric, but what is really cool is that you see the history of exactly what, how your trained performed over time. Right, so let's just go back here, and what we can do also is we can finish this run. So it's complete now, and yeah, it's just complete, and we can also see the artifacts associated to this run, which in this case there's one file and it's called hello world. It could be something much more interesting. Yeah, this is pretty great. Actually, one of the new features, I believe it was a 1.0 feature, was notes. You can see something like this is looking great, and your colleagues and why not can take a look at the comments also that we're adding. All right, that's kind of like the basics of MLflow tracking. You can kind of like use it for multiple purposes, and we'll talk about projects and models in a different in a different video. Now, what I want to do is, I know that this example was pretty abstract, like it doesn't, that doesn't make a lot of sense because it was just, to get you started. Let's try to do something a little bit more interesting, which is similar to this, but let's just try to actually, like do some actual training, right? And for that, we have a repo under the RStudio site, RStudio MLflow example. And what this repo has is just one simple example for MLflow. And what we can do is kind of like take a look at the dataset here, which is called wine quality. And it's just a CSV file that describes, different wines and, based on different parameters, an expert would, set the quality of that particular wine. So we can try to see if we can create a model that is kind of like related to this particular data set, right? So let's take a look at this. There's a file, there's this CSV file. And if you've followed some of our other multiverse videos, one of the things that we can do is we can use pins. And we can say pin wine quality. And this would be basically our wine file. And what pins does, it basically creates a local cache of a remote file, which is a great use of this particular case. So it's basically what pins is doing is converting a URL into a local file such that we don't need to re-download it multiple times, and why not? Anyways, unrelated. So now we have a file, and what we might want to do is, we might just want to load it. And I'm just going to use read CSV, so why not? And what we want to do is do wine file, and we can run this, and this should work. Now, if you were, if you're actually doing this properly, I think what you want to do is split this into, your training set and your validation set. I'm not gonna do that. I'm just going to use the original one as my training set. And let's just remove from our train set. Let's just try to let's just remove our quality, and we can take a look at the we just do view. We already run train. Yeah, we did. As you can see, there's a quality column, so let's just remove that particular column. And after we remove that particular column, we'll make our response variable just be the quality column. Let's just do that. All right, and again, like you can use these MLflow with any packages from the R ecosystem, right? Like if you want to do these with dplyr or why not, you can use it with whatsoever. It's like the functionality that MLflow provide, it's quite perpendicular to all the existing functionality that exists in the R ecosystem, so you can use them with all your packages. All right, and then like if you look at GLM, if you wanted to use glmnet. I'll just put it at the top in case I want to share this particular file. Maybe I'll share this in a gist, or why not? And yeah, so let's just include this library. If you look at GLM, at the definition of glmnet, you can see here that there's a few parameters. One is, for instance, lambda, right? And the other parameter that we have here is alpha. So those are two parameters that you might be interested in, understanding, how your particular model performs against different values of alpha and lambda. So as you might already have guessed, we want to use in this case log parameter, and the name of the parameter we can just call it actually alpha. And the value is gonna be, let's just set it to 0.5, and let's just say that this parameter is numeric. And let's just copy the same and call the next parameter. We'll call it lambda, and it's also numeric. We'll set the same value. And now when we train glmnet, what we can use is our features, our response, and then let's just set alpha equals to alpha, and then lambda equals to lambda, right? We're going to say that it's family Gaussian. All right, so this is what you would do. Now, before we get started with actually running this code, there's a few ways in which you can use MLflow. I would say there's three, right? Two, strictly speaking. So what we saw in the first half of this video, what we saw was using MLflow. I guess I would consider it implicitly, because one of the things that we kind of like assumed, or what happened in the background while we were using MLflow, right, is there is this concept of an experiment of and a particular run that got created with this particular experiment that we didn't have to define. We basically start using MLflow, and then we finish with MLflow end run, and the run got terminated and closed, right? And it was considered done. That's one way of doing it, but it's not the best way of creating an MLflow run. The best way to create an MLflow run, I would argue, is creating a run explicitly. So rather than doing this, what we're gonna do instead is we're gonna say we're gonna use with, and we're gonna say MLflow start run. So basically what this does, it creates a context for us to specify when the run starts and when the run ends. So what we want to do now is we want to do a few things. We want to, first of all, create our model, which we almost have. So we have created our model here. And then after we create our model, we want to create some predictions. And again, you should be using a test set and a training set. But just for simplicity here, we're gonna kind of like run our predictions on the training set. And here's another interesting concept to learn. There is a function in MLflow that will allow us to actually create the model, and this function is called create. And it's actually not a function from MLflow. It comes from a different package, and what this function does, it's basically it creates your it basically serializes. In this particular case, it serializes the actual model, and also the actual prediction function that you built. So in this particular case, when we create something, we want to create the model, which is kind of like the obvious part, but we also want to create the evaluation function. So the evaluation function here, we can specify with also using glmnet, and you should realize that when you're creating this prediction function, you should not depend on any environment or any environment variables or environment, and even contextual stuff. For now, like this closure needs to be self-contained. So we're gonna create the model, and the output needs to be also specified as a matrix, even though we kind of like will assume that it's a data frame. And that's pretty much it. So we have the prediction function and we have the model. Those are the two things that you need when we actually create the model for this particular entry. All right, so now what we want to do is we want to create the prediction. Now, in this particular case, we could have not created a model for this particular case, but I think it's just a good idea in general, because one of the great things about MLflow is that you can also log the model, and then you can actually run the model from, say, Python with a different set of parameters, or why not. So it's just a good practice to actually be able to create a model that would be understandable by MLflow later on. Okay, so this is our prediction based on our training set, whatever. And then, let's just create like a couple, the root mean square error, right? And then we say the root, the mean, the square, and the error, right? Which would be predicted minus the response. That's it. And we could have other ones, like the mean, absolute error, whatever. So we have our mean, our absolute, and our error. Oh, what have I done? Mean, absolute, and error. All right, so suppose that we have these two particular metrics that we want to track. So what do we do next? Well, we say MLflow log, and then we want to log the not a parameter in this case. We want to log a metric. So in this case, we can say that the metric is RMSE, and the value is RMSE, right? And then we have another metric to log, which is the actual mean absolute error. And what you should also do is, oh no, this is fine here. But one of the things that we want to do actually is when we're creating a proper script, what we want to do. So actually, this is fine. But what we want to do is we actually want to log also the alpha and the lambda. So because this only creates this creates a parameter, but the one that you want to define this is like this. You want to define first the parameter, and then you actually want to log it explicitly in your run. Log param. All right, so we have our parameters and we have our metrics, and that's pretty much it. So let me just save this, and we'll call it maybe, let's call this train.r. Yeah, so this would be how the script looks like, and on the kind of like explicit way of using MLflow. And then this means that when we run this particular code, basically whenever we run this particular code, we will, create a run on MLflow, and that run is just gonna get logged. And if we were using a server, like an MLflow server, we would have this centralized, and we would be able to share our logs statistics with our team and our models and our artifacts, and why not? So that's about it. Let's just try to troubleshoot this now. And we're coding this live, so could be the case that we hit a few issues. All right, so we're missing one package, which is crate. So we're missing an include, and as you can see from MLflow, here, let's see, we should be suggesting the package carrier, which also happens to be in CRAN. And what the package carrier does, it basically comes up with this single function called crate. Oh, I don't have carrier installed. Great. All right, let's just install that first. And yeah, what the carrier package really just provides is the crate function to create this model wrapper. We could actually skip it if we wanted to, but let's just go with this. And oh, predict this. We have a typo there. And let's see, predict not applicable to class. Predictor. Oh, sorry. We just call it. Should be fine actually. Have our predictor, glmnet, and we have our model, we have our matrix. Right, let's give it another shot. Model not found. Why is model not found? Object model not found. Where are the other instances? Right, so one of the things that we could do, or the way that I would troubleshoot this, is just go line by line. And then we can, this would be the, so we have the model, we have our crate, object model not found. So this means that basically our, probably our closure needs updated. So this is actually code that needs, that used to work on version 1.0. I probably should do a pull request to fix this one. So I'll do that. I'll follow up with a pull request and just get it done. So in this particular case, let's just simplify this a little bit, and let's just kind of like not worry about crates for now. Let's just straight out of the model, just run the prediction, which actually simplifies it for you, because if you're just getting started with this, you can just run the prediction and not have to worry about serializing the model. I'll actually leave that for a subsequent video. But anyways, so this should run the prediction. Oh, it wouldn't run the prediction because mostly I need to pass the actual train, which, you know, it's fine. You know, we already have you know, like train of Y here, and, you know, like we, you know, whatever. Sorry, not train of Y, train of X. Yeah, so we can run our predictions in predicted without creating the crate. We're probably missing to update kind of like some of the scripts in the tutorial that we have. And again, I'll just follow up on that after this video. Anyways, so now we have the prediction, and, you know, this should work, which is just creating our metrics. Why not? And then we can run these parameters explicitly. And then what we would do on the implicit, workflow would be to end our run. Now, instead of doing that, what we can do is just do that all together in a single step now that we have troubleshoot everything. So let's just go ahead and run everything. And just to make things a little bit more interesting, let's just, you know, like change the parameters. Let's just run it now with a lambda of 6, whatever. And we can run another instance. And let's run it with 1 of 7. And we can run this again. And we can change the lambda also and run it with 4, whatever. Right, so what we should be able to see here is, well, this is one of our experiments. But as you can see here, now we have a bunch of different runs for this particular experiment. And, you know, you should probably name your experiments to avoid kind of like mixing, you know, information between, you know, different scripts. We'll look into that as well. But as you can see here is that you have your actual parameters, and you have your kind of like also your metrics. So you can see here that we started with 0.5 in both cases for both parameters, and we have our metrics. And we can see that the error is actually apparently going down. So, well, lambda, we're increasing it, and the error went up when we increased lambda, and then went down when we decreased the value of lambda. And we could also do that with alpha, or run this through a, you know, hyper parameter optimization framework. And as long as we're logging things, MLflow will understand that. So as you can see here, like I was basically clicking, you know, like rerunning the whole code over and over again. There's one thing that you can do in RStudio which is actually quite helpful when using MLflow. And this would be to add a comment on the header and source the file. Well, source the file on your own. So we're going to say that, we're going to say here source on save. And what we can do here is override what we do when we, well, actually not override, but after we save the file, we can say MLflow, let me just type it here to get autocomplete. We can say MLflow run, and then the name of the file. Now, in this case, the name of the file, there's another way of parameterizing this in RStudio, which you can just say, what's the name of this parameter? I think it's entry point. Yeah, entry point. So you can just say source file. After sourcing the file, what you want to do is you wanna push this file to MLflow. So let's just try again and try it with different values of alpha. So now we're gonna do 0.4 of alpha. Let's also do 0.3. Is this working? Yeah, there you go. Right, so we're running now with MLflow, and we're kind of like pushing RStudio to run MLflow after we save the file. We might have broken something. Let's see. This is just a warning. This is fine. Yeah, this is all good actually. Well, actually, the error might have been fine. Let's just take a look here. Yeah, so we have a new run here with an alpha. Yeah, it's all good. So the output happens to be quite verbose when you're using MLflow run, which it's useful at times, but we don't need to care that much about that. We can run for 0.2 as well, and maybe we can do run for 0.7, or why not? And yeah, mostly this is another way to kind of like execute your particular models, and kind of like an easier way also of logging what's going on for your particular runs. All right, so kind of like this gives the basics of how to use MLflow, and specifically how to use the tracking functionality when you are using MLflow from R. And again, as I just quick recap, what you want to use are things like MLflow parameter to declare your parameters, and then log your parameters, log your metrics, and yeah, also log your models using the carrier package and the crate functionality. If you want to load your model, log your model, so you could do here something like MLflow log model, or more log artifact if you have additional files to log. All right, well, thank you so much for watching this video. I'm hoping that this gave you a brief but good overview of what MLflow is, how you can use it from R, and in general, how to do tracking with the MLflow project. And if you have, I should mention as well, if you have any particular, if you hit any particular issues, what I would recommend you do is go straight to the MLflow repo, and there is, like any other open source project, you can find most of the issues associated with R in this particular repo as well. So feel free to open a few issues, and we'll try to help you out. And specifically, I think the issue that you want to open when dealing with MLflow from R would be the R label, and we should be able to kind of like help you out if you hit any issues. One thing I should mention actually before we finish this video is that currently I'm using a Mac to run MLflow. You can also use Linux to use MLflow from R. It should be possible to use MLflow using Windows when you have a proper MLflow server running Linux, and use your R from Windows as a way of logging against your centralized MLflow server. However, currently it's not supported to run MLflow server in Windows. So yeah, just keep that in mind. If you're planning to follow up along from Windows, you are gonna hit some errors, and you would have to do additional work to install MLflow server on its own on a Linux machine, and then configure this particular configure the remote tracking UI as is specified on the documents in this particular section. Right, so this is all good. I hope, again, this was a useful video, and I'll keep you posted with additional features of MLflow as the year progresses. Thank you.